Lathe noises, lathe noises, lathe noises, lathe noises.
3 years in and I'm finally getting the hang of special effects on YouTube.
Hello Internet, my name is Quinn and this is Blondihacks. A tool that I've wanted for quite a while now is a micrometer stand. This is a quality of life thing that's nice to have in the shop, and I think I have just the right pieces of scrap in my junk bin to make one. So let's go.
For certain measuring jobs with a micrometer, you really need 3 hands. One example is if you're using a large micrometer with a telescoping bore gauge, it can be really difficult to hold everything just right while also manipulating the barrel on the micrometer and trying to get the right feel on the telescoping bore gauge. It's a whole big thing. Another example is if you have a whole bunch of small parts that you want to do inspection on, it can be kind of a hassle to have to hold the micrometer. So that's where a micrometer stand comes in, and I've got this guy from the bottom of a bin of stuff that I think was a donation to the channel, or it might have come from eBay, not sure. It's a Chinese clone of the Mighty Mag magnetic base. It's just a permanent magnet, and I think I can use it to make a micrometer stand. Over to the stockpile here, I've got a big bundle of 316 stainless round bar here. This was a recent donation to the channel, and this is a perfect use case, I think, for this. So I'm going to cut a length of this off to act as the primary bar for my stand. Length doesn't matter a whole lot, but 6 inches feels about right. So I'll cut a chunk of that off. I've also got this brass rectangular bar stock over there from the pile, and so I'm going to cut a couple of pieces of this, and I'm going to somehow make jaws out of it. I'm literally making this up as I go along. I have no plan or drawings or anything here. So I'll chuck up that round bar in the collet chuck, and I'll clean up the ends. Now, I do not have a lot of experience turning 316 stainless. I've done a fair bit with 303, but 316 is big girl stainless, so let's give it a shot here. I'm using Anchor Lube as a lubricant. It's recommended for stainless. It's supposed to be good. And I'll face off that end, and, well, I gotta say, that went super, super well. Stainless has a reputation for being extremely ornery to drill, especially 316, but for turning, I wasn't sure how it was going to go, but so far so good. And I put a chamfer on there, and yeah, that chamfer also went very well. This stuff gets hot, so you can tell that it's tough cutting, but the finishes that you get on it without much difficulty are very, very good. I'm actually really surprised by how nicely that turns. The other end has a big nasty factory pinch cut on it, so I'm going to do a little bit of turning to get rid of that. As much as anything, this is just an excuse to get some experience with a new-to-me material. Never turned 316 before. A simple project like this is a good chance to, push your comfort zone a little bit here and there and try out some new things in kind of a low-risk way. And yeah, that turns really, really beautiful. It's a little tricky to get it to break a chip, at least with these high-speed steel tools that I'm using. But boy, the surface finishes that you get with this are really something else. So now I'm going to push my luck, and let's try parting this chunk off that I just turned. This is the real test of my metal, so to speak. Well, it's making a nice chip there on the parting blade. It's definitely hot. You can see the Anchor Lube smoking up a storm there. And I can tell that it's very sensitive to surface speed, like it really needs to be perfect. So as I feed in, I'm gradually increasing the RPM. When it gets close to the middle, though, I can feel it cutting really hard, like it's really not happy even with more surface speed. So I think I'm going to stop here and not push my luck. I've got enough experience with this parting blade that I can feel when it's struggling and when something bad is about to happen. And I don't want something bad to happen in 316 stainless, because the loser is going to be me in that exchange. I'll finish this up with a hacksaw. I have to make short strokes because the saw doesn't have much room to move here on the lathe, but if you're wondering why the board is down there, that is why the board is down there. Yeah. And then once again, I'll just face off that hacksaw cut. And then I'll put a chamfer on this end as well to match the other end. And I gotta say, 316 stainless is now on my short list of preferred materials for pins and bars and other similar parts on future projects, because I really like the way that turns. A quick test fit here on the mag base, and it's a little stiff in there. So I'll clean some of the crud out of there with a reamer. Amazingly, the hole in this thing is the same size as this piece of round bar that I had, so that was lucky. Didn't have to turn anything. It came with this nice 80s aesthetic crappy plastic knob that'll tighten that bar in place. And so far so good. Off to a good start. Now, for the rest of this project, I'm going to use this little fellow. This is a tilting angle plate that was a donation to the channel at the Barzy Bash. Super excited about this thing, and I'm going to use it to create the angle that I need on the jaws to make a nice viewing angle for the micrometer. So I just kind of eyeballed what looked like it was going to be about right on the micrometer. I don't want to have to look straight down on it all the time because that means leaning forward over the bench, but I don't want it to be too angled such that I have to squat down to look directly at the lines. The first thing I'm going to do on the jaw stock is to drill the hole through it for the main vertical bar there. The angle of this hole is going to give the viewing angle on the micrometer, and this hole is going to be the reference for all future operations. Positioning an angled hole on stock is a little tricky because where it comes out on the other side is quite a bit different than where it's going in. So you can resolve that with a lot of math or CAD. My approach this time is just to put it in the center because I know this stock is quite a bit oversized in every dimension from what I'm going to ultimately end up with. And I'll just mill it down to the edges of the hole after the fact. So, you know, I'm cheating. But again, no drawings. This is a totally fly by the seat of the pants kind of project. So I had to make a flat spot there with an end mill since we're drilling on an angled surface. And then I center drilled, pilot drilled, and now I'm drilling through for the actual hole for the guide bar. It would be tempting to ream this hole, but I don't actually have room in this setup for this size reamer, so I'm going to drill it. But that's okay because the drill is going to make the hole a little bit oversized, which will give it a nice sliding fit on the shaft anyway. And I really should have drilled the flat spot that I started with a little larger because you saw when this large drill went in, it did engage the uphill side of the hole there first, which did cause some deflection in the drill, but it corrected itself when the bottom side engaged. Then the other jaw was drilled the same way, and I deburred all of those holes. A quick test fit there on the shaft, and that's got the fit that I want, so I think that's going to work out really good. Now I'll mock up with the stand, and oh no! Oh, the angle is the wrong way. I'm going to have to make this part all over again. You see it should be this way, like that. Imperial fist shake. I'm just kidding, you can flip the base around. All right, so that's looking good. The angle came out about what I wanted. So now I can move on to machining the other features on the jaws, and for that I am going to need my table to be properly dialed in here. I didn't bother when I first slapped it on there. So I'm just using the same method you would use for indicating a vise to get that guy straight to the x-axis. And then I'll zero out the table angle with a parallel there. And I'll double check that it's sitting flat on the top surface as well. It should be, but you know, there might be a chip under it or something. And I'm really not concerned with precision from here out. Everything's basically aesthetic, so I'm going to set up kind of a quick and dirty fence here to get the stock basically parallel to the T-slots on the table there. And I'll clamp those parts down as a pair like so. And I'll use the bar to hold them in that reference position, and then I'm just going to machine the sides parallel. They don't even have to be perfectly parallel to each other there because I'm going to machine them all the way down anyway. I'll start by cleaning up the ends of each and get them to the same length, and I'm just, again, milling them down to what looks like an aesthetically pleasing distance from the bar. No measuring here involved. Now I'm going to put the table back to 14 degrees, which is what I had just aesthetically decided was a nice viewing angle earlier. And then I'm going to side mill these blocks at this angle to create kind of a nice parallelogram effect. I angled it in this direction so that the cutter would clear the table, but it's not going to clear the locks, unfortunately, on the table, which I did not think of. So I could redo my setup, move them further down, or cut them on the other end of the table, something like that. But instead, I just tilted the angle the other way, and I did have just enough clearance doing this to have the cutter clear the table there. You can see that the stock is also sitting on a parallel to bring it up a little bit and give me some clearance. So this did the job with minimal setup redoing. And so I just side milled this all the way down until the sides of both jaws were cleaned up and in the same plane. Now, because clearance was tight here, I couldn't get the cutter past the bottom of the stock. So you can see that I'm ending up with kind of a super burr there that will be a little bit of extra work to remove. If I was thinking more clearly, I would have moved everything forward one T-slot so that the work was sticking out past the front edge of the table, but, you know, hindsight and all that. Then I just flipped the parts end for end and did the same cut on the other sides. Again, just lining up the existing cuts by feel. Again, this is all just aesthetic, so no super precision required here. You can see that side milling surface finish is not awesome. I'm cutting at the maximum length of the cutting flutes here, and this is asking a lot of my little mill, but it's okay, we're going to polish this all up later anyway. Then a file made short work of super burr, more like loser burr, am I right? What? That's not funny. Don't say things like that. And then I remembered I forgot to face the other ends, so back onto the table to finish that. So there's the outer surfaces of the jaws, all machined and looking pretty decent. Everything's lining up nicely there. I think it'll be a nice visual effect when it's done. So I'll do another mock-up here. Now you might be wondering what holds the jaws in position on the bar. And the answer is that I'm relying on the sag of the bar to cause binding on the jaws and hold them in place, rather like a lineman climbing a pole with one of those looping ropes. As long as the weight is on them, they stay in position. So every clamping mechanism needs a fulcrum, and that's how this is going to work. When the thumb screw tightens, it changes the angle slightly on the jaws and causes them to bind on the shaft, and then that becomes the fulcrum of the clamp, and thus the micrometer, which is out here, will be clamped correctly. And it will hold the two jaws in position vertically on the shaft. At least that's the idea. We'll see if it actually works here in a minute. I'm going to drill and tap for the thumb screw now, so I've got the bars set up again, same as before, and I've got a sacrificial block under them for the drilling, and I'm just squaring this up roughly with a square here. Again, precision not super critical. And then I'll mark what looks like a good place for the thumb screw. I'm putting it just over center so that you have some mechanical advantage with the thumb screw and the clamping. Once again, I made a flat spot with an end mill there, and this is not just for aiding the drilling, but this is going to be where the thumb screw seats down on there later. And then I drilled that through tapping size for my thumb screw. Now I need to clearance drill just the top jaw there. So I need to set the depth on the larger drill. And this is a little tricky with angled components. So what I did is I used a square to map the low edge of the part around from the end where I can see it to where the drill is. So it looks like it's much too deep here on the high side, but this is actually just barely deep enough on the low side. Working on angled parts like this can really mess with your brain sometimes. And now I can tap the lower jaw by running the tap right through the clearance hole in the upper jaw. And then I decided that the flat shoulder counterbore area there around needs to be larger, so I came in with a larger end mill and made a nicer flat spot for the thumb screw to rest on. The thumb screw will have a shoulder there that'll sit flat on that, because tightening a thumb screw against an angled surface would apply weird forces to things. So I just put a cap screw in here to give it a test drive, and that looks like that's going to work. I have enough parts now to see if my idea is actually going to work. So I'm going to slide the parts onto the vertical bar there, and then thread that cap screw in there for a test. I'll put the micrometer in there and tighten that down, and let's see if it binds up the way I hoped it would on the shaft, and indeed it does. It's a very secure grip, and you can still freely rotate it, which is kind of an interesting, unexpected feature. Over to the vise now, which I can stick the magnet to, and I'll do a little test drive here, and yeah, that works great. So you can see how a micrometer stand is intended to work. It saves you a hand when you're measuring certain objects, if you have to measure a lot of things, or if you have to measure tricky things like bore gauges. And when I loosen that bolt, it allows me to move it up and down the pole. Very nice. Okay, onto the thumb screw now. I measured the depth of the high side of the counter bore there, so I know how deep to make the shoulder on the thumb screw. And over to the junk bin, this piece of brass might, nope, giant hole in that. Okay, yep, that's the one. Let's make a thumb screw. This is a large diameter because I want the outer diameter of the knob to be pretty large for comfortable leverage. I turned the main part all the way down to the major diameter of my thread. Next, I set my depth with an indicator there on the carriage, and I proceeded to turn down the shoulder area that is going to sit down on that counter bore. So this needs to be turned all the way down to something that's larger than the thread, but smaller than the counter bore, so that it won't bind up in there. And after looking at that, I decided it was a little too large diameter for the thumb grip area, so I decided to turn that down a little bit. I want the knob to be large so that you have a good amount of leverage for a solid clamping action, but not comically oversized. And then I put a generous chamfer on the end, which makes the thread easier to start. I also turn the stock about 5 thou undersize when using a die. So in with the tailstock die holder now, and I can cut this thread. You can see I'm using the Tommy bar a few different ways here. I start with it in the center, and I'm pushing on it with the arbor using the tailstock. And that's really helpful when starting a thread in brass, because brass tends to just chew up that first thread and it doesn't start pulling the die in on its own. And then later I pull it out a little bit for more leverage, and then I finish up with using it incrementally on each side because the thread is long enough that it sticks through and starts to interfere with where the Tommy bar goes through. This tailstock die holder design has proven to be really flexible, and it's one of the better tools that I happen to have made here on the channel. And I'll double check and make sure that the counter bore is going to slide over that shoulder nicely, and it does. Then of course it's time for the knurling tool, because it wouldn't be a Blondihacks project if I wasn't knurling a brass knob at some point. I line that up on center, apply lots of WD-40, clamp it down a little bit so that it's turning with the stock, start the lathe, and then just crank it down a few turns on the scissors there. And stop it occasionally to check and see if the knurl is deep enough, and that looks good right there, so I will call it. Knurling brass is quite a bit easier than some other materials, so luckily this turned out well. And then I'll go in part way with the parting tool, so to speak. I'm sorry, I can't resist making that pun every single time. I know I'm a monster. And as I always say, the secret to a good-looking knurl is to chamfer both sides of it, so I will do that. And then I'll re-chamfer the end there of the thread as well, because the thread cutting die chewed it up a little bit. And that's looking good, so now I can finish off with the parting tool. And am I going to say it this time? I don't know, I might not, and Yahtzee! Oh, I did. Let's go ahead and test that knob now on the real thing. I'll snug that down, make sure I've got a comfortable amount of leverage there on the threads to get a good clamping action, and that looks pretty good. Over to the vise again for stability, and I want to try my largest micrometer as well. Make sure that my little thumb screw has enough leverage to comfortably clamp on the big one. At least this is big for me. This is a small shop and I make small parts, so for me, that's a big micrometer. That looks like that is working very well. Very secure. Yep, and it still rotates too, which is kind of fun. I'm pretty pleased with how that's going. Okay, so this is all functional, but the jaws themselves are a little drab, so I want to dress them up a little bit. And well, as I always say, chamfers are what separate us from the animals, so I will start by chamfering things. Now, chamfering a parallelogram shape is an interesting problem. These were milled at a 14-degree angle, so what I'm going to do is split the difference at 7 degrees and chamfer them from here. Now the idea is that with a 90-degree angle, the chamfering tool splits that 45-degree angle for you, and so by splitting the 14-degree angle, I'm theoretically balancing the chamfer angle on either side on each corner. The trick for this, though, is you got to go plus 7 degrees on one corner, the obtuse corners, and minus 7 degrees on the acute corners. I did not actually do that right, so some of my corners have technically the wrong chamfer on them, but it still looks nice. To make the chamfers line up on the corners, you can do a bunch of math, or you can just move in a little bit at a time until the chamfers line up nicely. If the chamfers are all on square corners, it's easy. You can just move in the same amount of depth of cut on each side, and the chamfers will line up. I wanted a little more though, so I thought I'd try using this chamfering tool in an off-label way. I'm going to use it kind of like an engraving cutter, and I'm going to put some Art Deco details on the top here. So I found a decent center line to start with, and then I moved to what looked like a good distance on one side of that, and then I milled it straight down some amount that felt about right, and then milled straight across to some other amount that looked about right. And I just noted the DRO positions after all of these moves so that I could make all of the little stripes look the same. So I'm pleased with that, and I went ahead and did the other ones. And then the top and bottom ones are slightly shorter than the middle one in kind of an Art Deco tradition. And that, it looks pretty charming. I think I'm happy with that. So the machining work is done, but everything's tarnished and covered in Sharpie, so I'll take it over to the Scotch-Brite wheel and give it a little shine for YouTube. Makes it look kind of like gold bricks on camera, which I always like. I mean, it's going to tarnish in a week anyway, but you know, for YouTube, you can imagine they look like this forever and I'm some sort of machining wizard, neither of which is even a little true. Hopefully final assembly now. I'll use my drill press vise as a base here. I don't know what my workbench is made of, but it's something non-ferrous because the magnet just really doesn't stick to it well. So that was a bit of a challenge on this project, but the drill press vise works. So I'll slide those two pieces together, install the thumb screw, and once again, install my micrometer, make sure that works as designed. And yeah, I'm very pleased with that. The grip is solid and it's very easy to install the micrometer. So I'll do a little test run here with a telescoping bore gauge, and you can see how having one free hand allows you to really get the feel down with the bore gauge. So that's great. I can slide it up and down to different heights if I want. I don't know why I would want to do that, but hey, you never know. And once again, with my largest micrometer, make sure that that is going to work well. And that clamps on there nicely. And here's a good test with a large telescoping bore gauge, because this is really where the micrometer stand shines, because I don't know about you, but my hands are not big enough to use these large micrometers and bore gauges at the same time. So that's the final result. I'm pretty pleased with how this turned out. It was a very quick couple of afternoons type of project with scrap I had lying around, and I think it'll be a functional thing for around the shop. Now I know I'm going to take heat for not repainting or otherwise spiffing up that cheap Chinese magnet, but you know, I kind of like the cheap 80s aesthetic of it, and well, I kind of ran out of time on this project. Thank you very much for watching. If you like this content and you can swing it, throw me a little love there on Patreon if you can. I really, really appreciate it. And I will see you next time.